Hello, we are now solving a question which is a what can I say? That is a living measure question. So let us see what can we do with this. So the question tells us let an be a sequence of Borel measurable set. Sorry, Borel measurable subsets of 0 closed interval 0 1. Okay. So now satisfying lambda of an equals to 1 for all n, where lambda denotes the Lebesgue measure on closed interval 0 1. So we have to prove that the intersection when our n belongs to n, that means the whole intersection, this is dense in closed interval 0 1. So now we are going to prove that the intersection is dense in 0 1. So we will proceed something. Okay. So now each an, let me write in another color. So yeah. Now we can see that each an is Borel measurable subset of 0 1 and with measure lambda of an equal to 1. So we need to show that the intersection is dense on 0 1, meaning that its closure is 0 1. That means this thing is equals to. So now the measure of the complement. Okay, so now for each n, the complement equals to closed interval 0 1 minus a. That has measure what? Lambda of a. This equals to minus this, that is equals to 0, because that is 1 minus 1. So that we can say that each complement is a null set. So now we are going to measure of union of the complements. Okay. So now consider the union of all complements. The measure of this union is bounded by the sum of the measures of the individual complements. So we can easily write it as lambda of this equals to, sorry, less than equals to summation n tends to infinity, sorry, n belongs to n, that is equals to summation 0 when our n belongs to n, that is equals to. Okay, so thus we can say that the union of those complements is also a null set. Now the measure of the intersection. Okay, let me just shift the screen. So we can write it as the intersection of the sets A n can be expressed in terms of their complements, which are this equals to closed interval 0 1 minus since our union of this thing the complements is a null set. So the complement of the complement this, that is also a null set. We can easily say that. So the measure of this will be this minus 1 minus 0 equals to 1. So our this thing has full measure in closed interval 0 1. Now the density of the intersection. So a set with full measure in closed 0 1 must be dense. Here's why. So suppose for a contradiction that our this set is not dense. Okay. So then there exists an open interval AB belongs to AB be a subset of this closed interval 0 1 such that our AB intersection this equals to 5. So now this implies what? This implies this AB should be a subset of the union of the complements. However, our lambda of AB equals to B minus A, that is greater than 0, while our lambda of the union of the complements is equals to 0, which is a contradiction. So the conclusion is what? Since our intersection AN cannot miss an open interval in closed interval 0 1, it must be dense on 0 1. Okay. Hope you understood, guys. Thank you.